Hello everyone, and welcome to today's session. In this video, we will provide a thorough understanding of the foundational data structures in R, lists, vectors, and matrices. These essential structures are core to data science, as the building blocks for data manipulation, statistical analysis, and machine learning workflows. Throughout the session, students will gain theoretical insights and practical skills, learning to effectively apply these tools to solve real-world data problems. By the end, you'll be well-equipped to integrate these structures into your data science projects with confidence. Let's start by exploring vectors. In R, a vector is a fundamental data structure that stores an ordered collection of elements, all of the same type, such as numeric, character, or logical values. Vectors are created using the C function and are essential for data manipulation and analysis. They are homogeneous, meaning all elements must be of the same type, and are indexed starting from 1. For instance, let's create a vector containing the numbers 34, 56, and 86, and assign it to a variable named A. By executing this line, you will observe the creation of the vector, which will appear in the global environment output, confirming that the vector has been successfully defined. We can perform various arithmetic operations on our vector. Let's begin by multiplying the vector by 2. The result will be displayed in the console. Next, we'll divide the vector by 4, and you can observe the updated result accordingly. Now let's go for a sequence. In R, a sequence is a set of numbers generated in a specific order, and it plays a crucial role in data analysis, iteration, and indexing. Sequences are integral to a wide range of programming tasks, allowing for efficient data manipulation and control flow. R provides several methods to generate sequences, with the most commonly used being the seq function, which offers flexibility in defining the start, end, and step size of the sequence. For example, let's create a sequence starting from 1 and ending at 10. After executing this line of code, you will see the result displayed in the console. It's important to note that if you don't explicitly define a step size, the seq function will generate numbers with a default increment of 1. Next, let's create a sequence ranging from 1 to 30 with an increment of 4. You will observe that the numbers in the sequence are separated by an interval of 4, reflecting the specified step size. At times, you may create a sequence without explicitly specifying the from and to arguments. By simply writing the numbers, R will automatically determine the starting and ending points of the sequence. To do this, simply follow the correct syntax, and R will handle the rest. Sometimes, you may need to repeat elements of a vector or list a specified number of times. In such cases, you can use the rep function, which stands for repeat. This function is commonly employed when you need to generate repeated patterns or create datasets with repeated values. For example, if we pass the number 4 as our argument and specify that it should be repeated 3 times, you will see the result displayed in the console. It's important to note that the first argument, x, represents the object, either a vector or a single value, to be repeated, while the second argument, times, indicates how many times the entire vector or element should be repeated. Let's continue by exploring matrices. In R, a matrix is a two-dimensional data structure that stores elements of the same type, numeric, character, or logical, in rows and columns. Essentially, a matrix is a collection of vectors organized in a grid-like structure, making it an ideal tool for handling data that is arranged in rows and columns. This structure is particularly useful in tasks such as statistical analysis, mathematical operations, and data manipulation, where the organization of data in a matrix form simplifies computations and data management. Now, let's create our first matrices using the built-in matrix function. We'll pass a vector containing the numbers 45, 73, 17, and 90, and assign it to a variable named B. Next, we will specify that the matrix should have 2 rows, allowing R to automatically arrange the data into the appropriate number of columns. By executing this line, the resulting matrix will be displayed in the console. Additionally, the by row argument can be specified. If set to true, the matrix will be filled row by row. If set to false, the default, the matrix will be filled column by column. Let me demonstrate how to use the by row argument with the previous example. By setting by row equals true, the matrix will be filled row by row. As a result, you will see that the numbers flow in a row-wise manner, starting with 45, followed by 73, and continuing in that sequence across the rows. You can observe the difference between the two matrices displayed in the console. It's important to note that if the by row argument is not specified, it is automatically set to false by default, meaning the matrix will be filled column by column. It is also possible to check the dimensions of our matrix using the dim function. Let's apply this function to our matrix and observe the results in the console. In addition, we can perform calculations on our matrix. For example, let's raise the matrix to the power of 3 by executing this line, and you will see the result displayed. Similarly, we can add 2 to each element of the matrix, and the updated result will be shown in the console as well. Continue experimenting with these concepts on your own. Hands-on practice will help reinforce your understanding and deepen your knowledge. Let's now explore how to access specific values within a matrix. To access specific values within a matrix, you can use indexing. By specifying the row and column numbers of the value you want to retrieve, you can efficiently access the desired element in the matrix. Referring to the matrix we created earlier, each element is identified by its row and column indices, which indicate the specific position of a value within the matrix. For example, to access the value 45, we would specify the row and column indices. By passing the argument for row 1 in the appropriate column, you will see that the value at that index is displayed when you execute the line. Let's now access the value located in row 1, column 2 of our matrix. Once you execute the line, the result will be displayed. It is also possible to create a matrix with a single column by specifying the number of columns the matrix should have. For example, let's create a matrix containing the values 5 and 6 and assign it to a variable named d. You will see the results displayed in the console. Before we continue, let's clear the console to help ensure a clearer view of the results. Let's now explore the list. In R, a list is a versatile and flexible data structure that can store elements of different types, such as numbers, strings, vectors, matrices, or even other lists. Unlike vectors and matrices, which require all elements to be of the same type, a list can contain heterogeneous data, making it ideal for more complex data storage needs. To create a list in R, we use the built-in list function. For example, let's create a variable named students and assign a list to it. This list will contain 3 components: names, grades, and attendance. The names will be John and Alex, with grades of 80 and 75, respectively. For attendance, we will assign true for John and false for Alex. Let's verify this by pressing the Enter key while holding the Control key. Upon doing so, you will see the list containing names, grades, and attendance displayed in the console. Accessing list elements. You can access elements in a list using either their index or name. For example, to access the attendance component of the list, we write students' $attendance. After executing this line, the result will be displayed in the console. Similarly, to access the names component, we can use the same approach by writing students' $names. The result will then be displayed in the console. Let's also explore accessing list components using indices. For example, to access the attendance component, which is in the second position of the list, we will use students E2A as the indexing number. This will allow us to retrieve the attendance data from the list. Next, let's access the names component using its index. By executing this line of code, the result will be displayed in the console. To gain a deeper understanding, it's important to continue practicing the concepts covered in this video. Hands-on experience will reinforce your learning and help solidify your knowledge. Thank you for watching this video. Remember to subscribe to our YouTube channel to stay updated with more content like this. If you found this video helpful, please give it a thumbs up. If you have any questions, feel free to leave them in the comments section, and I'll be happy to answer them.